When we hear about the word cryptography, what comes to mind? If we really dissect the word, we get the word graph. In it, that represents a diagram showing different kinds of variables. So cryptography means hidden variables or hidden writing. So cryptography is a method to secure or hide data using some kind of algorithm or code. In certain ways, you scramble the numbers or text that only few people can know the meaning of, or can descramble them. Nowadays, classical cryptography depends on the prime factors, hence mathematics. Also, there exists a secret key with which we can decrypt the data. Now, what is quantum cryptography? Unlike traditional cryptography, that takes the edge of complex mathematics, quantum cryptography works on the laws of quantum mechanics, which makes this technique much more secure. First things first, quantum cryptography deals with qubits, and the particles that are used as qubits hold certain properties in quantum mechanics. The particle exists in more than one place at a certain time. The particle cannot be copied at all, and if we observe the particles, we change its quantum property. Photons are mostly used as qubits. Now, to understand the mechanism of quantum cryptography, we assume that there are two parties, Alice and Bob. They are communicating with each other with the help of the photons. Suppose they wish to exchange a secure key for the message. The key is basically a stream of photons traveling linearly, but they are also in a mode of some kind of vibration. One photon represents one bit, either 1 or a 0, and now, before Alice initiates the message, photons pass through the polarizer. A polarizer is a filter that allows certain vibrations to pass in the same mode and let others to pass in a changed mode. For example, a polarizer can be vertical, horizontal, 45 degrees to the left, or 45 degrees to the left. On the other end, when photons travel through optical fiber towards Bob, Bob uses the beam splitter to read the polarization of photons. Bob does not know the mode of polarization beforehand, so he selects the mode randomly for each photon. At the end, Alice and Bob compare the sequence of polarizers used by both ends, and the wrong splitter is discarded. The rest of the photons with the correct sequence are used as a key. If there's an eavesdropper, then first things first, Bob has his leverage to talk to Alice and get information about the correct sequence of polarizers used. But the quantum advantage is if an eavesdropper tries to get in or try to read a photon, then the photon position is changed or modified, and that will be detected easily. We understood the basic mechanism of quantum cryptography. Now let's see some basic advantages of it. Quantum cryptography is very secure, as its encryption is dependent on the laws of physics. Quantum cryptography easily detects if someone tries to read the data. This is something that you won't find in classical cryptography. Also, quantum cryptography has multiple protocols. It could also use a combination of classical encryption to make the data more safe and secure. For now, quantum computers are in their initial stages, but the future of quantum cryptography seems to be very promising. Previously, the distance for quantum cryptography was limited to a maximum of 400 to 500 kilometers. Terra Quantum's development enables quantum cryptography keys to be transmitted over a distance of more than 40,000 kilometers. Instead of solving one problem at a time, with quantum computing, we can solve thousands of problems at the same processing speed, with the same processing power. Morris says. Michael Morris, CEO at Topcoder, a global network of 1.4 million developers. So, quantum cryptography, where the bizarre meets the fascinating to safeguard our data. Isn't it mind-boggling? With photons as secret messengers and a quantum edge against eavesdroppers, the future of cybersecurity takes a quantum leap. Are we on the brink of an unbreakable code? Dive deeper into the quantum realm with us. Hit subscribe and join us on this thrilling journey. Don't miss out on the future of cybersecurity. Signing off from Futuristic Tech and AI. See you in the comments, where mysteries await.